So happy to see you all here, my fellow nerds. I just landed this morning from Seattle, and I've really been enjoying soaking up the energy in the city. I used to work a few blocks from here, actually, when I worked at Patreon, and it's really awesome to be back. I'll share a bit more about myself and my background in a second, but I just wanted to show you first what you'll be getting in the next half hour. What you'll be getting is 4 key ideas that I think are going to revolutionize the way you think about language models. So here they are up front for you. I'm going to prove these ideas with 2 exciting demos. And once we put everything together, you'll realize that today's models are capable of something incredibly valuable that almost no one outside this room knows about yet. So today, we're going to answer a very simple but extraordinarily important question. Can you get a language model to control software? Because if you can do that, then you can have language models solve your problems just by speaking them or typing them. And that unlocks a whole new world of possibilities and actually changes the way we interact with software. So let me give you a few examples. Just last week, I had to delete a bunch of photos in my Google Photos app that I already had in iCloud. It's a boring, mundane task, but I had to do it to free up some storage and save some money on my Google Workspace bill. But it ended up eating an entire evening of my life. Another example. I don't even bother cleaning up my email anymore because it's just such a mess, and I know I'm not the only one. But imagine being able to say, ChatGPT, organize my email, or Claude, book a flight, or Gemini, open a bank account, and actually having a language model finish that task for you in seconds. I think this is an innovation that would be worth trillions of dollars of GDP growth for the entire world. Websites, native apps, and professional desktop software will be seamless to use because we'll be able to control them with natural language, and it'll all save an enormous amount of time so that at least I can spend my evenings on family, friends, and actually enjoying life instead of deleting photos. So let's start with some history. This is obviously a juicy target, and there have been many attempts to solve this. There was even the promise of voice assistants going back decades. But we saw how that turned out. It didn't turn out great. There's even work on AI agents leveraging function calling, and they're an emerging concept, but for now, they're mostly theory and simply don't work because our models just don't have that kind of reasoning and planning capability yet. There's been some approaches like multi-on, where a model tries to learn user interfaces and use the UI for you, but UI constantly changes. And have you ever watched someone use a UI really slowly? It's incredibly painful. So no to that. GPTs. A few days before the GPT store launched, I predicted it would mostly flop. And I think I was right about that. There were obvious warning signs. It's a closed platform with severely limited capabilities. GPTs can theoretically call APIs, but it's so awkward to do and proprietary, and the UX is so below the bar we're used to that it's no wonder we haven't seen them take off. They're just a minor improvement over plugins, which almost no one used, and OpenAI's actually sunset last week. But GPTs are toys compared to what I'm going to show you today. The best solution I've seen so far is actually Vercel's Gen UI concept that they demoed last Tuesday at AI Night. So this is pretty cutting edge. It gets really close with hitting the user experience bar that we're used to with traditional software, but it pigeonholes you into a very specific tech stack using Next.js and React server components. I think it's too inflexible, too coupled between the chat product and the actual product, and it leaves some fundamental problems unsolved. So, as an industry, we're all looking for a solution to this problem of making technology seamless through agentic language models. It would be like making science fiction real, but we keep swinging and we keep missing. But today, we're going to leapfrog all of these solutions that, no disrespect to the amazing, smart people working on them, don't actually work. But today, we're going to make it work. And we're going to do it through an open standard that's a win for developers, a win for companies training language models, and most importantly, a win for users. So I hope you're all excited. First, a little bit about me. My name is Shovon Hasan. Like that was mentioned before, I was on the payments and risk team at Patreon, building platforms to battle fraud at a large scale. And before that, I was at Amazon in the health and computer vision division on the front-end platform team as a front-end engineer there. So I know a thing or two about platforms. I'm on the internet everywhere as Enveo. My website's enveo.com. The best place to talk to me is on Twitter if you want to connect with me afterwards. I'm also Enveo on there. And of course, I'd love to talk to all of you in person as well. So let's dive into the first idea. And let's start with HTTP. HTTP is a wonderful battle-tested standard that allows any two computers anywhere in the world to send commands to each other in a fast, efficient, memory-safe way. From this simple standard, we're able to bootstrap the entire internet and the rich multimedia experiences that solve real-world problems that billions of people around the world enjoy every day, like watching movies, shopping online, banking, and more. So I think that HTTP is one of humanity's greatest achievements. HTTP is also just text, really just bytes, strings of ones and zeros. Language models output text. So do you see where I'm going with this? Text is all you need. The capability for language models to control software has existed all along. I'll prove this in the first demo. But before that, I want to prove a couple more things at the same time. I think the software industry has been doing AI completely backwards. Every company building AI features have been running models on computers that the user doesn't trust. And from the user's perspective, models running on other people's machines can't know anything about you, nor should they. I don't trust my authentication tokens and credit card details with Anthropic or OpenAI, and I shouldn't have to. So the interesting problems we could be solving, like having language models cancel subscriptions for us, apply for credit cards, organize our photos, give us directions home, are out of our reach until each company spends years of engineering effort to build, test, and maintain this entirely new arm of their technology stack. And even then, we end up with half-baked features that waste our time more often than they save it. This is called undifferentiated heavy lifting. And it's the reason we haven't seen the Cambrian explosion of AI solutions to our problems that we expected to see over the past year. So do you see how this is fundamentally the wrong computing model? This entire situation hurts developers, it hurts users, and it hurts the creators of language models. What we're missing is an open standard that allows companies to focus on developing their software and being experts in their domain, that allows language models to focus on building the most useful language models, and allows users to get their problem solved easily and securely. Let's talk about the third idea. This is the really big one. In the first demo I have for you, I'm going to prove to you that language models are capable of mapping a user's request to any API that we describe to the model. In a sense, you already know this. Language models already train on documentation for various command line tools like ls and ffmpeg, and are afterwards able to answer questions about them. So what if we created a standard where developers document their website's APIs, make them publicly available, and creators of language models crawl the internet for this documentation and train on them? They can adopt this standard incrementally, starting with even just one endpoint, and if they choose, their entire website. Market forces strongly incentivize these companies to adopt the standard because it opens up an entirely new source of traffic, and will be incentivized to pressure companies training language models to assume their API documentation, And language model companies are incentivized to listen because they're getting pressured on both sides from the companies, and users are going to flock to the language models capable of interfacing with any website through natural language, just because it's so easy to do. So let's hop into the first demo where I'm going to prove to you a few of these claims. This is a developer conference, so I trust you're all comfortable looking at a terminal. Let me full screen this after copying what I need to. So let's jump into Ollama. Ollama is a way of running state-of-the-art models on your own device. Now, mapping users' requests to appropriate HTTP strings sounds like an advanced capability that might require advanced reasoning. So you might guess that we need a giant multi-trillion parameter model like GPT-4 to do it reliably. But it turns out you actually don't. You don't even need a several 100 billion model parameter like GPT-3.5. And you don't even need a 70 billion parameter model like Llama 2. We're going to do everything today with just a 7 billion parameter model running on this laptop you see in front of you. So let's jump into, I had caps lock on there, into Mixtral. Yeah, let's do Mixtral. Mixtral's pretty good. I actually did this with Mistral. Sure, let's try Mixtral. It's going to take a second to load up. But what we're going to do is we're just going to set the system prompt here. And we're going to paste in this giant thing. But let's just break this down for a second. At the top, we have some contextual information like the current date and some information about me, like where I live, an auth token for the flight booking service example that we're going to stick to today. And this simulates the kind of information you trust a language model running on your local device with. You could trust it with your credit card, just like you do with your browser. The rest of this system prompt includes an API description for that flight booking website. And that's all this is. And at the end here, we have some basic prompt engineering stuff like if you do a bad job, I'm going to be fired. It seems to help. But enough talking. Let's paste this in and just start interacting with this API. So the website here allows you to book flights. Yeah, it actually gave away the first example where I was going to ask it for a flight to JFK, but so let's just do SF instead. I need to fly to SF tomorrow. And you see it outputs an HTTP string formatted as JSON for readability. And it does a couple key things. It is able to fill out the appropriate departure date in the correct format. So it understands today is March 5th and tomorrow would be March 6th. And it was even able to map the fact that I lived in Seattle to the Seattle airport code. And I was even able to do the same thing for the San Francisco's airport. It also knows I'm pretty cheap and it flies economy. That one I think is just the default. So it does a pretty good job of that. And from this simple string, it's only one more step to take this and pass it to my browser to actually fetch this website, which you can all go to right now, and get back some flight information. But the awesome thing here is it's a conversation, so I can keep chatting to it. So if I made a mistake and I say, actually, no, I want to fly to NYC, we should see everything stay the same because it's contextual. But the one thing that it needed to change, it did. And everything else is exactly what I'd expect. And notice how this kind of capability naturally emerges from the model. I didn't have to create a vector database with positive and negative embeddings. I didn't have to upload any documents for retrieval augmented generation. I didn't even have to fine tune it. Imagine how much better this can get if the API definitions are included as part of the model's training set and then RLHF to work flawlessly. In fact, if RLHF sticks around as a method, I could even imagine companies being involved with providing the feedback to make sure things work exactly the way they want for their business. So this is the concept that is the foundation of everything else I'm going to show you today. Let's jump back into the slides. Yeah, sure. Let's close that. So let's recap. We proved that given an API definition, a model can map a user's problem, in this case, looking for flights, to a string capable of interacting with a website that can solve the user's problem. We proved that this can happen on a model running locally, so we can trust it with private information about us, like where we live and our auth tokens, same as we do with our browsers. And all of this running on the GPU of this MacBook in front of me, not on a stranger's supercomputer on a data center hundreds of miles away. So this kind of functionality is already too cheap to meter. And finally, we proved that from the point of view of the developers of a web application, in order to enable users to interact with our app via natural language, that developer doesn't need to spend weeks or months or apparently even years, as we're seeing the industry slow to move, to build out features and complicate their tech stack. They just need to write a single text file describing the way to use their website. In fact, the thing I pasted into ChatGPT, into Mixtral there, I actually had ChatGPT generated for me. So it took seconds, not months. So these are massive industry-wide problems that we just solved. The final idea is this. But for this one, I think it's best if I just show you what I mean. So let's jump into the second demo and see what this kind of functionality could look like as part of an actual chat product. So, whoops. Let's go to ami.nvidia.com. So this is a live website you can all visit today. You can see I was doing some testing before. And let's do the same thing. I need to fly to SF tomorrow. And we see the same output we saw from Mixtral, but when it finishes, we're able to take that string and actually request a website and embed that live website into my chat. So this is loaded in via an iframe, which I'll show you. And you see the fields filled out with the exact values you'd expect. Seattle to San Francisco with tomorrow's date. In fact, it even omitted the return date because I didn't specify it in my original request. So we see 2 flights. These are all made up, obviously. And I want to emphasize, this is a completely different website embedded into my AI chat. And notice I can interact with it as a standalone app. I can even change stuff around, like maybe I want JFK instead, and I want to click around in the UI. Let's change it back to SFO. Or we can type to it. I meant NYC. And the same thing will happen where it changes to JFK and it updates the UI. And this is a completely live website. I can even see my current bookings. And we can see we have no bookings. In fact, I can even use my browser back button and it does exactly what you'd want it to do, which is to go back to the page you are on. So the key takeaway here is I don't have to sacrifice a single thing. I can use an app the way I enjoy using an app, which is natural to me, or I can chat with the app. Isn't that incredible? This is possible, by the way, because the destination website in this case, I also made this website. It safe listed the URL of this chat application for cross-origin requests so that the website can put that safeguard in place to protect their users. This is just one of the many security features that you get for free when you build on top of battle-tested standards like HTTP and HTML. This is why I'm not shopping on Amazon for this demo, by the way, although that would be much more interesting. Amazon hasn't safe listed my little chat application yet. So let's do the really meaty thing, which is to actually book a flight. There's been, by my estimation, billions of dollars poured into research and development to make language models capable of doing things in the real world. Useful side effects if you want to be academic about it. But HTTP has been able to do that since the 90s. It's called a post request. And you might have heard of it. But we're going to get a little technical here. To send a post request to book a flight, I need the flight's UUID. And that's a programmatic concern that's not exposed to the user. But I have a trick to solve this. when we fetch this website, what we get back is HTML. And HTML is also text. We can embed that text into the conversation so that the language model has all the context it needs to get the UUID or anything else to map it to the API of the website. So in this case, I've structured the website so that each of these elements are links to the actual flight, and they have a UUID. Let's see if I can dig through these. Yeah, here's the A tag, and you can see the UUID here. It's really small, so let me make that bigger. Oops. And because this text is embedded, and we've described the API of the booking endpoint to include this UUID, if I were to ask it to book the first flight from Seattle to SFO, we see 2. Let's ask it to book the first flight after noon, because I like to sleep in. We should see it start to output a post request with our authorization token this time. And if we were to now go to the bookings endpoint, we now see it's been booked. We were able to do this through post requests. This is a level of productivity that's previously unimaginable. I was able to book a flight with 2 sentences of text. Okay, I think we have time for this. I don't have time to fully dive into this today, but I want to tell you about it anyway. So I completely agree with Logan here that chat is not the end game for AI. I don't know about you, but I find an empty chat box kind of intimidating. Like when you're at the grocery store and you see 30 different types of cereal, I think the way we prefer to use the internet is we all have our favorite websites, and the websites that we use should be center stage. We should just be able to talk with them if we need to. And that functionality should be built into the browser. This will be possible as models get smaller and smaller and more capable. So, to sum everything up today in one sentence, we proved it's possible to connect any website to any language model. And the magic here is that we did it through an open standard that allows us to get it done in seconds and minutes, not in weeks, months, and years. And the experience users end up with is incredible and makes 0 compromises. So I'm really excited about this idea. I hope you are too. I envision a world where we connect the billions of people on Earth with millions of useful websites that solve our problems. So I want to leave you with a term to encapsulate everything we talked about. We're all familiar with the term API, which is the application programming interface. It's a way for software to describe itself so that other software can use it. And what I showed you today is an evolution of that concept. I call it the application model interface, the AMI. It's a way for software to describe itself so that language models can use it. And rather than replacing any existing software, we're adding a new way to use it, an intelligent way. I think this is an incredibly valuable concept that supercharges the capabilities of language models and the internet, and we can achieve it with minimal effort, incremental adoption, and in a backwards compatible way. In the future, I envision a binary protocol to HTTP, but for native applications like professional desktop software like Adobe Premiere or Excel. So that's really all I have for you today. I'm really glad I came back to San Francisco to give this talk because the builders I've talked to here understand the value of this proposition. Billions of people stand to benefit from ensuring this kind of capabilities is free, open, and easy to develop for as possible. Every internet company stands to benefit from adopting this because users are going to want a way to browse the web just because it's so easy to do it this way. And there's so much more to talk about in terms of security, combating bad actors, and optimizing performance. But for now, I just want to ask you for your help. And the next step is simple. Demand more from the language models you use every day, like ChatGPT and Claude and Gemini. Demand that the complex problems that you have in your day-to-day life can be solved by these language models. And over time, I think these companies will listen and they'll all agree to an open standard similar to this so that we can all save an enormous amount of time. So thank you. It's just a system prompt, just like the first demo. So you don't even need to fine tune it. Okay, that would raise the cost of it, which is a good thing. Ultimately, you'd want to inject that kind of information at the training stage. The difference is that when you actually look at the stuff I pasted in, the description for the endpoints were in plain English. So if my screen's still being shared, I can show you a bit more of that. The descriptions for the endpoints were actually written in natural language themselves. And obviously, a regular piece of software can consume that. But it's a perfect way to describe your software for a language model, where you describe the response and the request format in natural language. So that's why this is a separate concept to APIs. Horrors errors for sure. I was unsure if I would be able to do it. Next.js does not make it easy. I actually have the Next.js documentation bookmarked here. It's my probably most used bookmark.